In this video, you will learn about composites of mappings. Now, when we say composites of mappings, what does that even mean? Well, the word composite or composition means a combination of more than one thing. All right, so a composition of mappings would mean that we have more than one mapping put together. All right, so that's our definition. It's more than one transformation that is used to produce an image. So for example, okay, right here, we could start with translation of point P to take you to P prime. All right, and then we can do another translation, so we call that T2, of P prime to take you to P double prime. So this would be a composition because you are doing two different translations. You're translating P to P prime and then P prime over to P double prime. So in math notation, we can write this in the following manner. So we have T2 of T1 of P equals P double prime. So notice the order, by the way. This is kind of like function notation with algebra, where you start inside parentheses first. So that's why the T1 is here in parentheses. You transform or translate point P with the translation 1 first. And then from that, we do the second translation. So that's why the T2 comes over here and then T1 on the inside, even though you're doing translation 1 first. Okay, and that's the reason. And then another way of explaining this or writing this in math notation would be seen right here. So this would be in mapping notation. The first one would be function notation. So with mapping notation, instead of the double parentheses like we have, we could use this little symbol right here. So it's a raised circle. It's like a little tiny dot, but it's an open circle right there. So that little open circle right there means a composite or a composition of mappings. All right, you're putting the two translations together. All right, so notice again the T2 comes first, the T1 comes second because, all right, the T1 is closer to the P. That's what you're doing first. Just like with the function notation, same thing with mapping notation. All right, and that would be mapped or equal to P double prime. Now take note that with a composition of mappings, that the order of the mappings usually does make a difference. So not always, but it usually makes a difference. So meaning if we do the first mapping and then the second mapping, it would make a difference if you do first followed by second versus the second followed by the first. Okay, the order makes a difference. And then a composition of isometries would still be an isometry. So if you do like a reflection followed by another reflection, all right, both are isometries, so the result would also be an isometry. All right, so that goes for any combination of mappings. Let's take a look at an example. Here we have point P. Okay, so point P, if we translate it over here with T1, translation 1, that takes you to P prime. And let's say we do our second translation to take you down to here, that takes you to P double prime. So this notation, or what we see here, this picture, is a picture of what we saw over here with the notation. All right, we do translation 1 followed by translation 2, that takes you to P double prime. So we could just say, to get from P to P double prime, we have the T2 composed with T1. So translation 2 composed with translation 1. All right, and that would be the quick way to get from point P to P double prime. So that would be an example of what we see over here. Let's take a look at some other examples. So here we're going to work with function notation a little bit because function notation is kind of the same thing as with mappings. So here if we have two functions, we have f of x equals 3x and g of x equals 2x squared. We have two different functions or mappings, and what we're trying to find is a composition of f and g. All right, so we want to find f composed with g and then of x. Now remember, this notation is the same thing as f of g of x. So I personally prefer writing it in this function notation because it's more familiar and it's easier to see with the parentheses that we begin here in the innermost parentheses. So we begin with the g of x first. All right, so when you do this, okay, you start with the g function first, even though it's written second, and we can replace the g of x with this 2x squared. So we have f of 2x squared. All right, and then this right here, this is replacing x. So notice here it's in place of x, meaning we plug it in place of x right here in that function. So the 2x squared goes in here for x to get 3 times, and then 2x squared. And 3 times 2 is 6, so that gives you 6 times x squared. So we could say that this composition of f of g of x, it maps x to 6x squared. Now if you did it the other way, where you did g composed with f of x, and you found what this is equal to. Okay, it's going to be the same process where you can write this as g of f of x, and we start with the innermost function of f of x. So in place of f of x, we can plug in the function 3x to get g of 3x. And this 3x is in place of x in the g function. So look here, in place of x, we now put a 3x. So in place of x here, we plug in a 3x. So now we have 2 times 3x squared. And then 3x squared would be 9x squared, and multiply by 2 to get 18x squared. So we can say that g composed with f of x maps x to 18x squared. So we had some practice here with the function notation, but also pointing out the fact that the order makes a difference. Right? These are not the same thing, 6x squared and 18x squared. So the composition of those functions are not equal. So we've kind of verified indirectly that these compositions, the order does make a difference. Okay, now looking at mappings, what if we had this notation right here along with this picture, and we were told to compose this half turn with the center at O, and compose that with that would be a reflection, that's a regular R, reflection, across line M. So if you're reflecting and doing that with point P, so assuming we're working with point P, we begin with this first. Remember, we start with this second one first. Okay, so you begin with the reflection. Even though it's written second, you start with that one first. So you reflect point P across this line. When you do that, you get to this point over here, P prime. And then this notation right here is a half turn around the center point of O. So half turn means you go around 180 degrees, and it's going to take you right over here. All right, so that's going to take you to P double prime. All right, so that would be the composition of those two mappings. So we compose those two to get to our final destination of P double prime. Okay, now we're going to try to change the order of the composition. So we're doing the same mappings, but we're changing the order. So same picture, same points, same line, but now we're starting instead with the half turn first. So again, it's written second, but with the composition, we do this one first. All right, so if we take point P and do a half turn around point O, it's going to take you over here 180 degrees to this point. So we've done the half turn, and then we have to do the reflection of P prime across line M. That's going to be this right here. So we reflect point P prime across, and that takes you over here to this point, and that would be our P double prime. So notice that these two compositions are not the same thing. We do not get the same result. P double prime is pretty close to line M, whereas P double prime for the first picture is a little further away. So notice that these compositions are not equal. Okay, so we verified indirectly again that the order does make a difference. Now let's try to look at a composition of reflections. So we're going to do two reflections. We're doing it with this crescent moon over here, and reflecting this, we'll call it P, across line M and then across line N. So when you reflect this shape across line M, we're going to get this new shape over here. All right, and then we reflect again across line N, and we now have this picture over here, this image. So notice what happened. Okay, we have our beginning picture, and now it's translated over here. So the two reflections with the parallel line actually created a translation, because our end image is the same as the original. It's not flipped or anything. It's just moved over to this new location. So that is a fact. With two reflections across parallel lines, it creates a translation. Now let's take a look here with lines that are not parallel. So now we're just trying to reflect point P, so a point, not a shape, but point P, across line M and then across line N. So if you reflect P across line M, we get this point over here, P prime, and then reflect across line N to get P double prime over here. So it's maybe a little more difficult to pick up on this, but when you have two lines that are not parallel, the two reflections will create a rotation. And the rotation is about this intersection point right here, this point O. All right, and the angle of rotation can be calculated by taking the angle. So if we take this angle here of those two lines that are intersecting, call that y. Okay, if we double that, that's going to be the angle from P to O to P double prime. All right, so that's going to be the angle of rotation. That's the relationship. So that new angle, or the angle of rotation, is twice the length of, or twice the measure of the angle of the two intersecting lines. Now let's take a look at one more example of reflections. So here we're going to look at perpendicular lines. And again, we are just dealing with point P. All right, so just a point, not an entire picture. But we reflect across line M and then line N. Reflecting across line M, we get point P prime right here, and then reflect across line N to get P double prime down here. What happens with perpendicular lines is that we have created a half turn, all right, with the center point at O, right? So if we go from P to P double prime, okay, what we've created is a half turn. It's 180 degrees. All right, so that's the fact about perpendicular lines and reflections. If you have two reflections across perpendicular lines, that will create a half turn. And that concludes our lesson for today. We will see you next time.